Okay, so this is me looking at the second type of projectile, and that's a projectile that instead of being projected from a height and falling off a cliff, for example, is a projectile that's actually projected upwards and then falls back down, usually to the same height at which it falls. And I've put a link to the questions I'm using on the description of this video even, but if you can't get to that, you can always press pause and just do the question from the screen and then press play to watch me answer it. And my advice would be to do one question, watch me answer it, do the next question, watch me answer it. We are starting with question 2 because question 1 is this type and you have a whole video of those that you can look at, so we're going to start here. So we've got a photograph showing an athlete performing a long jump, and we're told that at takeoff his horizontal speed is 8 meters per second, so this is 8, and his vertical speed is 2.8 meters per second, which means they've been quite nice. They've split up the overall velocity vector into the vertical and horizontal components for us, which is very nice of them. They might not have done that. They might have told you what V is and given you an angle and expected you to work out that this is V cos theta and that this would be V sine theta, but they've done it for you. So there we are. So step 1, I'm going to draw 3 suvats, and my suvats are going to be in the following sections. I'm going to look at this bit, which is vertically up. I'm going to look at this bit, which is vertically down, and I'm going to look at the whole thing, which is horizontal. Okay, so vertically up, vertically down, horizontal. I'm going to draw this unusually so as a table because I can't be bothered writing suvat 5 times, but I can be bothered drawing that many lines. So I never do that. There we go. I nearly did it with a capital A, and that kills me. Right, let's think about what's going on. So I don't actually know currently how high up he jumps, and therefore I also don't know how far down he jumps. But I do know that his initial horizontal speed is 8 meters per second, and his initial vertical speed is 2.8 meters per second. I also don't know his horizontal distance because I'm going to learn that later on. I know that vertically upwards stops when I get to 0, and then that vertical down starts at the same point at 0, and also that this will be minus 2.81 meters per second because if he reaches the ground at the same time as or the same distance I should say, that he jumps up, then these are symmetrical. And for all things vertical, I know that acceleration is minus 9.81 meters per second squared, and the time I currently don't know. Horizontally, I know the acceleration is 0 because it always is. That's the point of horizontal motion, which means the final speed isn't going to change from the initial speed. And I do know that this time is going to equal up plus down. And I also know that time up will equal time down. So, firstly, show that the total time the athlete spends in the air is about 0.6 seconds. Assume his centre of gravity is the same height at takeoff and landing. That means he's starting and ending at the same height. And there are many ways to do this. I go for a brute strength method, and I'm going to think about vertically upwards. And I want to work out a time. I've got V, U, and A, and I need to know T. So I'm going to use V equals U plus AT and rearrange that to say T equals V minus U divided by A. So that's 2.8 minus 0 divided by minus 9.81. And I weirdly get a negative time, but I'm going to ignore that for now. It comes out as 0.285 seconds. Now, that isn't like 0.6, you might be crying, haha, but the time equals the time for up and down, so it's going to equal 2 times 0.285 seconds, and that therefore comes out as 0.57 seconds, which does round to 0.6. Calculate the horizontal distance jumped by the athlete, really common thing to do. So let me just fill these in. I know this is 0.285 and this is 0.285. Therefore, I now know that this time, as I've worked out here, is 0.57. So looking at this, I know everything except for S. So I'm going to use the equation, the standard one for horizontal, of S equals UT plus 1/2 AT squared, and all of that disappears because A equals 0. So S equals 8 times 0.57, and that comes out as 4.6 meters. Happy days. However, they're going to complicate things here and say, in reality, when the athlete lands, his centre of gravity is 50 centimetres lower than the position at takeoff. calculate the extra horizontal distance this enables the athlete to jump. So what we're seeing instead is this. They're going to land further down than they started. And we want to think about this little section. And there's a few ways you can do this, but a clever little one is I'm just going to think about this section here, okay, and draw 2 more suvats. So I've got a vertically down suvat for this section here. And then the horizontal suvat for this section here will be pretty much the same as this, but the time's going to be different. So vertically down, during this little section here, I know that he travels 0.5 meters. I've written minus because he's going downwards. And I know that at the start of this journey here, he's traveling at minus 2.81 meters per second, because that's what I worked out before. I also, I've put 2.81 there. That should just be 2.8, sorry. I think I was thinking of 9.81 acceleration due to gravity. I do, however, know that acceleration due to gravity will be minus 9.81 meters per second squared. And I don't know what v is going to be. And I don't know what t is. I don't really care about v. I want to find time. But if I want to do an equation, I just put across there, that only has s, u, a and t in, I have to use s equals ut plus half at squared. And that's a tricky one to use when trying to find time because it appears twice, and once as a not square and once as a square. So what I am going to do is find v. I'm going to say v squared minus u squared equals 2as, and put the numbers in there. So v squared equals 2as, which is 2 times minus 9.81 technically, but also then times minus 0.5, so they cancel out, plus u squared, which is 2.8 squared. And I cannot worry about the minus sign there because when I square a minus, it becomes a positive. So v is, if I do all of those sums and then square root it, don't forget to square root it, you will get, I don't know because I haven't actually written it down. So I've written the next step down, but I'd like to tell you what it is. So 2 times 9.81 times 0.5, which is just 9.81, should have worked that out, plus 2.8 squared. And then must square root that, I get that v equals 4.2 meters per second. Now, why do I want to do that? Because now I can say v equals u plus at, which is a lot easier to use. T equals v minus u divided by a. So it equals 4.2 minus 2.8 divided by 9.81. I'm ignoring all of those minus signs because it makes life easier. And I get that the time is 0.14 seconds. So it takes 0.14 seconds for that extra bit of fall, for that extra 0.5 meters. So in that extra bit of fall, that extra 0.14 seconds, I can think horizontally, and I can say s equals ut plus 1/2 at squared, but the acceleration is always 0. So it equals u, which will not change, it's still 8 meters per second, times 0.14. So 8 times that equals 1.14 meters. There we are, done. So that's quite a tricky question. I'm not going to lie. I got it wrong. I've had to do it twice because I made a mistake in part C. So if you found part C quite difficult, you're quite normal, don't worry. But we're going to go on to question 3 here. Okay. So question 3, a student investigated the physics of football. She used the equations of motion to model the behaviour of a ball when kicked at different angles to the horizontal. She predicted the height of the ball when it reached the goal, presuming it was kicked from the same place with the same initial speed each time. Hard to do, but there we are. The results are shown in the table, and we can see that as we increase the angle to the horizontal, the height of the ball when it reached the goal is increasing. And it says, state the significance of the negative value of the height for an angle of 10 degrees. What is the significance of the negative value of 0.78? I can't see that it's negative. I think maybe there's meant to be a minus sign here, because otherwise there isn't a negative value. So what would this mean? Well, it's going to mean that if it's got a height of minus 0.78, that means that its displacement is less than where it started. So if they kicked here and the height at which it ended up is minus 0.78, it's here. Now, obviously that can't happen. So it must be that the ball has hit the ground you could say it bounced or something like that, because obviously when it hits the ground, it's not going to go in the ground. It's not going to sink unless you're on really, really muddy ground. So that's difficult because you can't see the minus sign, but it must have been there. Okie doke. On the diagram below, sketch and label the predicted path of the balls for angles of 20 and 40 degrees. Now this time the 1 meter is a plus, so we're okay there. So if I call this 1 meter, I know that the first one, the 20 degrees, ends at 1 meter, and then 40 degrees ends at 4.7 meters, so it needs to be quite a bit higher. So the first ball is going to do something like this, and then the second ball is going to do something like this. Okay, so this is going to be 40 and this is going to be 20 degrees. That's all the kind of legwork. The really important question is this one here. It says, during a football match, the ball is kicked towards the goal at an angle of 15 degrees to the horizontal from a distance of 11 metres as shown. The ball has a diameter of 0.22 metres and an initial speed of 26 metres per second. By means of calculation, determine whether or not the ball will pass into the goal. You may ignore the effects of air resistance. And currently I'm feeling quite panicky because I have not worked out if this is going to work or not, and I haven't thought about it, but let's just apply the usual rules of SUVAT. So I know what I'm going to do. I'm going to think about, so this journey will look like this, and basically we need the goal to be anywhere from here onwards. If the goal's over here, then we're not going to score the goal because the ball will hit the ground before it gets there. So I'm going to do my 2 SUVATs. I'm going to move this over a little bit, so hopefully you can see up here. I'm going to do 3 SUVATs actually, vertically upwards, vertically downwards, and horizontally. Okay, I'm going to draw myself a little table. It's my new method when I'm being lazy and don't want to write out SUVAT 5 times. 1, 2, 3, 4, 5. I don't mind writing lines apparently, but I do mind writing letters. So SUVAT. So vertically upwards, we don't know how far it travels, but we do know that its initial speed, we don't know its initial speed. Hang on, it has initial speed of 26. So the initial speed is 26 meters per second, and this angle here is 15 degrees. So vertically, the speed is going to be 26 sine 15. So U is 26 sine 15. Next time I should draw these boxes a bit bigger. I know that vertically upwards, when it gets to this point here, it's got a speed of 0, and it's always minus 9.81. I'll write G for ease there, and I don't know time. Vertically downwards, I don't know S. I know that U will be 0 and V will be 26 sine 15 if I'm looking at the whole journey, which I might not do actually. And I know that A is minus G, and T, I'm not sure. Horizontally, I know that they've got a distance of 11 meters, but I might not be using that one. So I'm going to put it in a bracket and I'll explain why in a minute. U is going to be 26 cos 15 because I care about the horizontal initial speed. So 26 cos 15, as will be V because acceleration is 0, and T, I don't know. Right, the thing I know most about is vertically upwards. So I'm going to work out vertically upwards what is the time. Have you been told how high up the goal is? No, we haven't. I definitely took a question out here as well, which might not help me in terms of the diameter. Right, so vertically upwards, I'm going to say V equals U plus 80. And then rearrange that to say T equals V minus U divided by A. And then that's going to be 0 minus 26 sine 15 divided by minus 9.81. Let's do that as a sum. So 26 sine 15 divided by 9.81. I get that this takes 0.686 seconds. Okay, now I'm going to work horizontally just for a moment, just to see if something works. Like I say, I'm doing this blind. I'm going to do S equals UT plus half AT squared. And I know that half AT squared equals 0. And I want to know how far that the football travels in this time. So I've got that in 0.686 seconds, S equals 0.685 times U, which is 26 cos 15, times 0.686. So times 26 cos 15. And that is equal to 17 meters. So if that equals 17 meters, that means it's going to get into the goal. Okay. Now the problem is, will it go over the goal? Here we go. I've got 2.4 meters here. So I know now, I'm going to draw it here, that here's the goal, here's the football. Actually, let's not draw the, I can draw the goal. The football is still going to be on its up stretch as I get to the goal. But if the goal is too high, then it's not going to, and it'll get in it. If the goal's too short, it might go over the top. That's really badly explained. Very sorry. So we want to think about how long does it take. This might be completely separate. Maybe this is the way we should have done it all along. We're going to work backwards and think, okay, what's the time it takes for the ball to travel those 11 meters horizontally? So horizontally, S equals UT equals 26. Oh, hang on. No, I need to do a time there. S equals UT. Therefore, the time it takes for it to travel 11 meters is S over U, distance over speed, equals 11 divided by 26 cos 15. 11 divided by 26 cos 15 comes out as a very big surd, which is T equals 0.438 seconds. So now let's work out how high up, here we go, how high up is the ball at this time. I'm going to work vertically upwards and say S equals UT plus 1/2 AT squared. This was the way to do it all along. I just kind of led you along there. S equals UT plus 1/2 AT squared. UT equals, doesn't equal 0. It equals something for certain because it's 26.15. So S equals 26 sine 15 times 0.438 plus 1/2 times 9.81 times 0.438 squared. So my answer was 0.438. Let's just check that's still in there. I'm going to square that, times it by 9.81 and times it by 0.5. And I get that's plus 0.94. S here is 26 sine 15 times 0.438, which is 2.97. That seems quite big for that. 26 sine 15. Oh no, that's not. That's quite a big number. Times 0.438. So we've got 2.97947. Now, I'm just thinking of something here. I've made a mistake. I know where I've made the mistake. This needs to be a minus 9.81. This is why it works. There we go. Hopefully you haven't just thought the video broke. This is a minus 9.81 because it's always minus, which makes this sum here a minus 0.94. So I get that S equals 2.94 minus 0.94. S equals 2 meters. So can the ball get in there? Well, we need to count the fact that the diameter of the ball is 0.22. So the top of the ball is going to be S equals 2 plus I think it's going to be 0.11 meters. Because oh no, we care about it cake to the bottom, isn't it? So yeah, so 0.22 equals 2.22 meters. Can't see any of that. Which is smaller than the height of the goalpost. There we go. So it's going to go into the goal. Right, so we're just proving here that these questions are quite tricky because luckily I didn't have to do that one again because I hate having to edit videos together, but there we are. Let's do a couple more, because who isn't a martyr and who doesn't like to make life difficult for themselves? Hopefully we'll find some nice easy ones, but we'll see. Right, question 4. The monkey and the hunter is a thought experiment, so to illustrate the independence of the horizontal and vertical motion of projectile. It's one of my favourite experiments in physics, although it's a bit mean to the monkey. A student models the experiment by projecting a table tennis ball horizontally at a toy monkey. The ball and the monkey are initially at the same height, 0.25 metres above the bench. The monkey drops at the instant the ball is projected. The monkey and the ball will always meet irrespective of their horizontal separation. So firstly, show the time taken for the ball to fall to the bench is about 0.2 seconds. Apologies, you've not been able to see all that question. So if you want to have a go at the question, there it is. I'm doing terribly on this video, I'm very sorry, but I'm not doing it again because it's taken me forever. So I'm going to do some suvats. I'm going to think vertically downwards and I'm going to think horizontally. Suvat. So it falls 0.25 metres. My H is a little bit too far over there, but oh well. And it falls with an initial speed of 0. We don't know v. It's minus 9.81, and we don't know time. And then horizontally, we don't know the distance. We know the initial speed. We don't know anything right now. So we'll come back to that. So the time taken for the ball to fall to the bench is about 0.2 seconds. So I've got S, U, don't know V, A, I need to know T, so I want the one without V. So guess what? S equals UT plus 1/2 AT squared, but UT disappears because it's 0. So T equals 2S over A, all square rooted, equals the square root of 2 times 0.25 divided by 9.81. So 2 times 0.25 divided by minus 9.81 equals square root, always a good thing to do. Square root, no, that's even worse. 2 times 0.25 divided by 9.81. Square root the answer. There we are. T equals 0.23 seconds. Remember to always write it to one more significant figure. The ball is projected with a horizontal velocity of 2.6 metres per second. Calculate the horizontal distance that the ball should travel if the ball is to hit the monkey as it reaches the bench. So now we know that this is 2.6 and this is 2.6. We always know that's 0. And the time is going to be 0.23 from there. And we want to know the horizontal distance that the ball should travel if it's to hit the monkey as it reaches the bench. So if it's reaching the bench, that's when it's fallen this long, which has taken 0.23 seconds. So I'm going to use S equals UT, standard, plus 1/2 AT squared, but this one disappears, and then S equals 2.6 times 0.23, which is 0.59 metres, which is the answer, which is good to know. A variation of this experiment is where the monkey is initially higher, so that the ball has to be projected upwards towards the monkey. The two objects will still always meet. Complete the diagram above to show the path of the ball and the monkey. So the monkey's going to fall, and the ball will go into projectile motion and do something like this. But they'll always meet at a point here. If the ball is projected with a velocity of 3 metres per second at an angle of 20 degrees to the horizontal, if the monkey is met at a horizontal distance of 0.5 metres, how far will it have fallen when it meets the ball? Okay, so what we need to do is we need to work out the time it takes for the ball to do this, and then how much the monkey will have fallen in that time. So this is a bit of a tricky one. I'm going to think about a horizontal suvat for the ball. So horizontally, the ball is travelling 0.5 metres. And its initial speed is going to be 3 cos 20 horizontally, because it's cosy, so this will be 3 cos 20. And its final speed will be 3 cos 20, because its acceleration is 0, and I need to work out its time. So guess what I'm using? S equals UT plus 1/2 AT squared horizontally. And this all disappears. S equals ut, so it equals 3 cos 20 times, I don't know the time, I know the distance. So therefore I can say that 3 cos 20, no, let's just start that again. Time equals S over U equals 0.5 divided by 3 cos 20, and that comes out as 0.5 divided by 3 cos 20, not with the answer, 0.177 seconds. Okay, then monkey. I'm going to do a suvat for the monkey. I'm going to do the suvat for the monkey falling. We want to know how far he's fallen. He starts at 0. We don't know how fast he ends up at. He will be accelerating at minus 9.81 because that's, you know, what monkeys, everything does. And then time I know is 0.177 seconds. So to work out S, guess what? S equals ut plus 1/2 at squared. Ut disappears. S equals 1/2 times 9.81 times 0.177 squared. Square that times 0.5 times 9.81. The monkey has fallen 0.15 metres. I really hope that's correct. Perfect, got it right. Okie doke. So that was a bit nicer, I think, for that question. And we're going to ignore question 15 because it's not very suvat. And we're going to have a think about question 6. I really can't read. What is going on with me today? Last one we're going to think about is question 6. So pause if you need to do the question. The photograph shows an arrangement used to launch a light foam rocket at a school science competition. The rocket is launched at the level of one end of a long table and lands at the same level. Oh, thank God for that. So it's going to do this. Nice and simple. The students measure the horizontal distance travelled by the rocket, which is 1.88 metres, and the time for that is 0.88 seconds. And it show the horizontal component of the initial velocity of the rocket is about 2 metres per second. So what we're doing here is we're remembering that the horizontal component, so if I say that this is the speed u, and this is theta, the horizontal component is u cos theta, and the vertical component would be u sine theta. But what I need to remember here is that the horizontal component is always going to stay steady. So if I just do a little quick suvat here horizontally, can you see that? Yeah. I know that horizontally, I'm told it travels 1.88 metres in 0.88 seconds. And I know that A equals 0 and V equals U. So if I want to work out U, I can do S equals ut plus 1/2 at squared. We always use that. And say that U equals S over T horizontally, which is 1.88 divided by 0.88. And 1.88 divided by 0.88 equals 2.14 seconds, which is approximately, meters per second, which is approximately 2 meters per second. Then show that the vertical component of the initial velocity of the rocket is about 4 meters per second. Now for this one, I'm going to think vertically up and write suvat. And I don't know how far up it travels, but I do know that the initial vertical velocity is u sine theta, but I don't know what u is. So I'm looking for that still. V is going to be 0 on the vertically up bit. I care about this part of the journey. A is minus 9.81 meters per second, and T is 2.14 divided by 2. Okay, so I'm looking for U. I don't know S, so I'm going to use V equals U plus AT. V equals 0, so therefore U equals minus AT, which equals minus 9.81 times 2.14 divided by 2. So divide that number by 2, times it by minus 9.81, and then minus that, because of the minus there. Sorry, that's minus, so it becomes plus. Oh, I didn't like that, did it? 2.14 divided by 2 times just 9.81. I like it easier. Oh, what have I done there? There's nothing wrong there. V equals U plus 80. 2.14 That's stupid of me. This is all right that up there. I'm just going to start again for some reason. V equals u plus at. Therefore, u equals minus at equals minus 9.81 times time. This isn't time, this is speed. Time is 0.88, so I'm going to do 0.88 divided by 2. This should be 0.88 divided by 2. So 0.44 is 0.88 divided by 2 times by 9.81 comes out as u equals 4.3 meters per second, which is about 4, which is much better. So calculate the initial velocity of the rocket. This is quite a nice question for 4 marks. We know that vertically, really late, it's 4.3 meters per second, and that horizontally it's 2.14 meters per second. Why I've drawn that bigger than the vertical one, who knows? I'm very tired. So I need to work out the overall velocity, which is going to be the square root of 4.3 squared plus 2.14 squared, because it's Pythagoras. So let's square that, plus 2.14, answer plus 2.14 squared, square root the answer, it doesn't like me today, does it? Equals 4.81, or 82, if I'm going to round it, meters per second. But that, it says velocity, so I need a direction as well. And I'm going to go for this angle here. So I know this is 2.14 and this is 4.3. This is the opposite, this is the adjacent. So I'm going to say tan theta, because it asks us there, and it asks to the horizontal, equals op over adjacent equals 4.33 divided by 2.14. 4.33. And I'm going to shift tan that. So theta equals 63.7 degrees. So the answer, I'm going to write 4.82 meters per second and 63.7 degrees. Then on to some wordy bits. The students obtain their data by filming the flight. When they checked the maximum height reached by the rocket, they found it was less than the height predicted. Suggest why. There's always an answer to this. Air resistance was ignored. And we'll slow down the rocket. And then give 2 advantages of filming the flight in order to obtain data. There's lots of these. You can rewatch it. You can slow it down. You can zoom in. It eliminates human reaction time, which is a really annoying thing. Lots of them. Right, there we are. 4 questions, 32 minutes, a couple of hairy moments, very long day. So very sorry that that is not my most polished of videos, but hopefully useful nevertheless.